Okay, so today we're looking at inverses of functions, and simply put, what everything we're going to talk about in this video comes down to is the swapping of the x and y values. So the inverses will undo each other, and like I said, what that comes down to is swapping the x and y values. We can see that in a very nice example. Let's say we have a relation that's defined by a couple of points, a couple of coordinates. So let's say that -1 goes to 2, and 3 goes to 7, and 5 goes to -8. If I wanted to know what the inverse of this function was, or of this relation was, like I said, inverses are going to swap the x and y values. So the inverse of this relation, notice here with this relation, if I quote-unquote plug in a -1, I get a 2 back out. If I plug in a 3, I get a 7. And if I plug in a 5, I get a -8. Another way to say that is -1 maps or corresponds to 2, 3 maps to 7, and 5 maps to -8. In the inverse, that will be swapped. 2 will bring me to a -1, 7 will bring me to 3, and -8 will bring me to 5. So like I said, it's just the x and y values are swapped. Now, as we look at the equation of functions, then finding the inverse is going to be a little more involved, but we got this. So let's look first. How do we know which functions have an inverse that is also a function? Because those are going to be the ones that we are most concerned with. So if you recall previously, we have a method to determining if a relation defines a function or not. So let's look at this relation right here. If you recall, we have what's called the vertical line test, and we use this test to determine if a relation is in fact a function. Reminder of how the vertical line test works. Vertical line test says that if I can draw a vertical line at any place on the graph and it only crosses one point or touches at one spot on the graph, then we know that the relation is a function. So we can see, boop, I could draw a line here, I could draw a line here, I could draw a line here. Everywhere that I draw a vertical line, it's only crossing at one point, so I know that this is a function. We have a very similar test to determine if the inverse is going to be a function as well. So is the inverse a function? I'm going to abbreviate that FNCT for function. So, like I said, a very similar test. We're going to hone in on our graphing skills real quick. So let's say g of x is equal to the square root of x minus 3 plus 2. If you recall our transformations, how do I graph this? I know it's the square root function, so the parent function starts at the origin and boop, off to the right. These transformations are to the right 3 and up 2, so to the right 3 and up 2. So there we go, something to that effect. So to determine if the inverse of this function is in fact a function, we have what's called the horizontal line test. And like I said, the horizontal line test is very similar to the vertical line test. The only difference, only two differences, is that we are drawing horizontal lines, and instead of determining if the original relation is a function, we're determining if the inverse is a function. So the horizontal line test, I'm drawing horizontal lines, and if I can draw a horizontal line at any place, every place on the graph, and it only crosses one time, then we know the inverse of the function is also a function. So we can see that this is going to pass the horizontal line test. Woohoo, it passed. So we know that this is g of x, so we know g inverse of x is a function. So let's come back up to the first example here where we did the vertical line test. So this one passed the vertical line test. We know that it is a function, but is its inverse a function? So you probably, without even doing the test, know that no, it is not. I can draw a line just in this spot right here, and it crosses at 2 points, so I know that this is going to fail the horizontal line test, which means, let's pretend this was f of x. So it means that the inverse, whatever the inverse of this function is not a function. So this failed this failed the horizontal line test, so we know that the inverse is not a function. All right, so jumping back to our g of x example, we sketched the graph of g of x, we performed the horizontal line test, and it passed, so we know that the inverse of g of x is in fact a function. So what actually is g inverse of x? So let's actually find the equation of the inverse. So find the actual inverse. There's a couple of methods to finding the inverse. The one that we're going to focus on is the switch and solve or swap and solve method. I call it the switch and solve. You can call it whatever you want to call it. So like I said at the beginning of the video, inverses more or less just switch the x and y values, and we're going to hone in on that to be able to find the actual inverse. So we'll start by switching or swapping the x and y values, and then we'll solve for y. So our function was g of x equals the square root of x minus 3 plus 2. This is actually y equals the square root of x minus 3 plus 2. And again, we are going to start by switching the x and y values. So everywhere there's an x, I'm going to put a y, and everywhere there's a y, I'm going to put an x. And then we will solve for y. So I have x equals the square root of y minus 3 plus 2. So I switched, and now I will solve. This is a square root function. To get rid of a square root, I need to square it, right? Those are inverse operations, so they'll undo each other. But in order to square it, I need the square root all by itself first. So I need to get rid of the plus 2 since it's on the outside. So I will subtract 2 from both sides. So I get x minus 2 equals the square root of y minus 3. I now have that square root all by itself, so I can go ahead and square both sides. I'm not going to distribute, I'll just keep the left-hand side as x minus 2 squared. On the right, the square and square root cancel, so I get y minus 3. And I want to solve for y, so I need y all by itself, so I will add 3 to both sides. So I end up that y is equal to x minus 2 squared plus 3. Right? We added 3 to both sides. I just switched them. And this is our inverse. So g inverse of x, you can't see that. There we go. G inverse of x is x minus 2 squared plus 3. So there is our inverse. And we can even take this a teensy step further. If we know the domain and range of the original function, then we can easily say what the inverse, what the domain and range of the inverse are. Because remember, domain is x and range is y, and inverses just swap the x and y value. So coming back up here to our original function, square root of x minus 3 plus 2, it might even be easier to look at the graph, whichever one is easier for you to identify the domain and range. But domain, again, is talking about the x value, so I see that this function picks up where x is 3 and goes off to the right, so x is going to infinity, so my domain is 3 to infinity with a bracket. And the range, the y values start at positive 2, and albeit slowly, it is increasing, so it's going off to infinity. So this is the domain and range of the original function. So the domain of the original function becomes the range of the inverse, and the range of the original function becomes the domain of the inverse. So for my inverse, we can write down the domain and range. Scooch this up a little bit. So for my inverse, the domain is the range of the original function, so 2 to infinity, and the range is the domain of the original function, so 3 to infinity. Alright, let's do one more example of finding the inverse. Kick it up a notch. So let's say f of x is equal to 2 over x plus 5. And I want to find f inverse of x. So we'll start off by everywhere there's an x, put a y, and everywhere there's a y, put an x. Remember that f of x or g of x or whatever of x, this is just our function notation, so this is our y. So I have x equals 2 over y plus 5, and now I'll solve. This equation has a fraction in it, so I'm going to multiply both sides by that common denominator. On the left, I have x times y plus 5, so I'll go ahead and distribute. I get x times y plus 5x equals, on the right, the y plus 5's cancel out, leaving me with 2. I am trying to solve for y, so I want everything that has a y on one side, everything else needs to go to the other side. 5x does not have a y, so I'll subtract it from both sides, so I get xy equals 2 minus 5x. And now to get y all by itself, I just need to divide by x. So y is equal to 2 minus 5x all over x. So f inverse of x is equal to 2 minus 5x over x.